Welcome back to Aurora Tech Channel. Today, I will review the Sovol Zero, an ultra-compact 3D printer that's even smaller than the Prusa Mini and the Bambu Lab A1 Mini. It's based on the Voron Zero platform, but instead of shipping you a box of parts to assemble, Sovol adapted the design for large-scale manufacturing, made several modifications, and turned it into a fully assembled, ready-to-use machine. So, let's take a closer look at what the Sovol Zero has to offer. As of today, the retail price is $429. It's a fully enclosed Core XY machine. The enclosure is made of metal with a glass top and a glass door that can open 180 degrees. The base is built on a 6mm thick aluminum plate that adds extra rigidity, bringing the total weight of this tiny machine close to 40 pounds. The build volume is 152 by 152 by 152 millimeters. For the motion system, it uses linear rails on all three axes, and the print bed is supported by dual lead screws with a timing belt under the base. The claimed top speed is 1,200 millimeters per second with 40,000 millimeters per second squared acceleration. Inside the print head, you'll find a dual gear metal extruder, a strain gauge for automatic Z offset, an eddy current sensor for high-speed auto leveling, and an accelerometer for input shaper calibration. There's a single cooling fan in the print head and an auxiliary fan at the back of the printer. The Hutton can reach 350 degrees Celsius in just 2 minutes, thanks to its ceramic heater. The claimed max flow rate is 50 millimeters cubed per second. It comes with both a brass and a hardened steel nozzle in the box. The AC heated bed can reach 120 degrees Celsius in just 5 minutes. With the enclosure closed, the internal temperature can easily exceed 50 degrees Celsius, making it stable enough for printing ABS, ASA, and other engineering-grade materials. It also includes a strong exhaust fan with a built-in filter, allowing you to print PLA, PETG, and TPU without needing to open the top cover or front door. It runs native Clipper firmware on an MKS Pi motherboard, featuring a quad-core 1.5 GHz processor, 1 GB of RAM, and 8 GB of eMMC storage. The screen is the classic Clipper LCD, but there's also an expansion port that supports a color touchscreen like the one on the SV08. It supports Wi-Fi, Ethernet, and offline USB printing. The web interface is using main sail, and Sovol provides Orca Slicer profiles so you can run everything locally, no cloud services needed. For remote control, you can use the open-source Obico platform to monitor and manage your prints via phone or browser when you're away from your network. Overall, the Sovol Zero's hardware looks robust. It's like a tiny beast. So I'd like to thank Sovol for sending us this machine to review and for sponsoring today's video. As always, even though this is a sponsored review, we won't hesitate to point out any cons. With that said, let's get started. The box of the machine is compact, but it weighs over 40 pounds. The corners are well protected, and the entire machine is placed inside a bag so it can be lifted easily. Since the glass door and glass top are already installed, foam and airbags surround all sides for added protection. Besides the machine, we have an LCD screen, spool holder, filament sensor, Wi-Fi antenna, a cover for the exhaust fan, some basic tools, a user manual, and a power cord. We just need to connect the touchscreen and mount it at the front, then screw the Wi-Fi antenna onto the side. The filament sensor is also mounted on the side, and the spool holder goes on the back. That's all we need to do before connecting the power and turning on the machine. As it doesn't have a color touchscreen, we'll use this simple Clipper text-based screen and select calibration. It will set the Z offset by using the nozzle to probe the bed, then calibrate the input shaper. Now we'll load some filament and start our first print. I'll begin with the preloaded super fast benchy, which has an estimated print time of 8 minutes and 40 seconds. The startup routine begins by heating the nozzle in bed, then cleaning the nozzle on a silicone pad located at the front left. Next, it cools the nozzle and sets the Z offset. After that, it uses the eddy current sensor to measure the center of the bed and then scans the entire print area. Since the sensor scans instead of probing, the auto leveling process only takes a few seconds. It then returns to the corner and heats the nozzle to the printing temperature. This benchy is printed near the back, close to the cooling fan, to ensure the filament cools as quickly as possible. We'll perform a flow test later to show the difference between printing close to and far from the auxiliary fan at the maximum flow rate of 60 millimeters cubed per second. We'll let it complete a few more layers and then do a sound test. With the door and top cover open, the sound level reaches up to 70 decibels, with the fan being the loudest source. When the door is closed, the noise drops by a few decibels, though not significantly. When fully enclosed, the sound level stays in the high 50s and occasionally peaks in the low 60s. The print finishes in under 9 minutes. For a benchy printed at 0.25mm layer height and high speed, the result is decent. The lower section surface quality is better than the upper part. Cooling in the front looks good, as the auxiliary fan is strong and the model was printed close to it. The top is a bit rough and the line width appears wider than usual. Next, we'll set up the printer in Orca Slicer and slice another benchy for comparison. Sovol included the profile on the USB drive, and I believe it will be integrated into future releases of Orca Slicer like other Sovol machines. Let's take a look at the speed settings in the profile. The first layer prints at 55 millimeters per second, which is similar to other clipper machines. The walls print at 350 to 400 millimeters per second, which is quite fast. Infill is printed at 500 millimeters per second, while top layers and supports slow down accordingly. The printer travels at 1000 millimeters per second, which is extremely fast. For acceleration, it peaks at 40,000 millimeters per second squared, and the walls print at 10,000 to 12,000 millimeters per second squared. Let's load the benchy. I'll send the print over my local network. To set the SSID and password, you need to edit a text file on the USB drive, insert the drive, and turn on the printer. It will then connect to your network. You can use the LCD menu to check the IP address. I'll just enter it here. The connection appears to be working. Using this profile, printing a benchy takes around 28 minutes. Looking at the speed, some areas print at up to 350 millimeters per second. The flow rate reaches close to 30 millimeters cubed per second in those high-speed areas. Let's send the print to the machine. In the Device tab, we can see it's now preheating. The print finishes in 31 minutes. It's pretty obvious which one is which. The normal 0.2mm profile produced a much cleaner result, the surface quality is better overall, and the cooling is more even compared to the high-speed print. I would probably not use the settings from the 8-minute benchy profile unless I just need a quick prototype. For other test prints, I'll stick with the standard profile. Then, we'll do some benchmark prints, starting with the number slider for clearance. The print finishes in 2 hours and 15 minutes, which is about 20% faster than the average time of the latest Core XY printers. The top looks decent, with some stringing, and the bottom looks good. The tiles adhered well to the bed. All tiles can move freely. Next, I'll print my simple geometric model to see if the parts can fit together. The print finishes in 1 hour and 9 minutes, about 15% faster than average. On the square side, it clears up to 0.075 millimeters and gets partially stuck at the tightest 0.05 millimeters, just one step away from perfect. On the cylinder side, it clears up to 0.05 millimeters and stops at zero clearance, which is a perfect score. Then I'll print the mini Honeycomb box to test the extruder's retraction performance. The bottom isn't printed very well. I noticed more stringing than expected. The honeycomb patterns on the sides look better. The extruder manages to extrude a tiny bit of filament and retract immediately. The print finishes in 2 hours and 33 minutes. On the sides, all patterns printed completely, though stringing is slightly above average. The bottom didn't come out well, some patterns are unclear, and there's quite a bit of stringing. Compared to other machines that printed well with this model, the side isn't too bad, just slightly more stringing. However, the bottom is clearly not as good as the others. Next, I'll print the Robo Alpaka to test surface quality. Since the model is a little over 200 millimeters tall, and this printer's Z height is only 152 millimeters, I'll cut the model in half and print both parts on the same plate. Printing in 2 parts adds a few extra layers to the top of the lower half, but the estimated 3.5-hour print time is still pretty fast. This model usually takes 4 to 5 hours on other new generation machines. The print finishes in 3 hours and 28 minutes. The surface quality isn't bad, so I'll glue the parts together. Let's take a look from all 4 angles. Now we'll compare the same model printed by other machines, starting with the Sovol SV06 Ace I tested earlier this year. The surface quality is similar, but I think the SV06 Ace looks slightly better due to its slower print speed. Compared to another low-cost Core XY printer, the Elegoo Centauri Carbon, the Zero is a little faster, but the Centauri Carbon has slightly better surface quality. Compared to the Creality K2 Plus, the K2 Plus is the clear winner in both speed and surface quality, but of course, it's also much more expensive. When compared with the Prusa Core One I tested last week, the Zero is about 25% faster, but the Core One's surface quality is noticeably better. Compared to the fastest printer ever, the FLSUN S1 Pro, it finishes 1 hour faster, thanks to its delta kinematics and even sturdier frame. It also delivers better surface quality than the Zero, but of course, the S1 Pro costs 3 to 4 times more. So, while the Sovol Zero does print faster than most machines, the high speed does slightly affect the surface quality. However, it's still within an acceptable range when judged on its own. Let's try some different materials, starting with TPU. I'll print a TPU tire. The flow rate is set to 3.2 millimeters cubed per second in Sovol's filament profile, so the actual speed will be limited to around 40 millimeters per second, regardless of the speed and acceleration settings you use. The print finishes in 28 minutes. The surface is clean, and the inside of the model is also printed well. Next, I will print a PETG pen holder. The first layer looks good, and it didn't get over-squished, even at the higher temperature needed for PETG. I'm using VOXELPLA PETG Plus and the built-in profile and Orca slicer. The flow rate is set to 25 millimeters cubed per second, which is almost the same as PLA. The print finishes in 1 hour and 53 minutes, much faster than the average 3-hour time for this model. This time, the surface looks beautiful, the bottom adhered well, and the inside is clean. A perfect print. So far, one thing I don't really like about this printer is that the spool holder is located at the back. I've designed a side-mounted spool holder and a mount to relocate the filament sensor. The height of the model is only 93 millimeters, which is fine for this printer, but the length is 185 millimeters, which is too large. So I'll cut it in half and print it in 2 pieces. The first part will take 1 hour and 7 minutes, and the second part will take 1 hour and 11 minutes. I'll print them with ASA. I set the bed temperature to 120 degrees Celsius, and once the printer is fully enclosed, the internal temperature rises quickly. My room temperature is currently about 22 degrees Celsius, and it reaches 40 degrees Celsius shortly after printing starts. The first layer also looks good at the maximum bed temperature. The first part finishes in 1 hour and 18 minutes. The second part finishes in 1 hour and 12 minutes. Both parts printed very well. No warping or layer cracking. I'll glue them together and use clamps to press them tightly. After that, I installed 2 magnets. As there were only 2 screw holes available on the enclosure, it ended up working just fine. And I'll go ahead and print the filament sensor mount using PC-CF. But first, I need to change the nozzle. The printer includes 1 spare brass nozzle and 1 hardened steel nozzle. Simply use the included wrench to unscrew the current nozzle and tighten the hardened steel one. The flow rate for PC-CF is set to 12 millimeters cubed per second. I used 50% infill, and this print finishes in 40 minutes. This part is also printed beautifully. I need this small mount to relocate the filament sensor. I think this setup works really well. We'll talk more about this later. And now, I will also do a first layer test. Overall, the first layer wasn't too bad, but it seems these areas didn't stick very well. I could still peel off the whole sheet without it breaking. Since the Z offset and bed leveling were both working well so far, I expected better results. Printing the first layer at 105 millimeters per second is a bit too fast. Even on other fast machines, it's rare to see the first layer printed at over 100 millimeters per second for regular prints. I decided to slow it down to 50 millimeters per second and print it again, which is more in line with most other printers. As expected, the result was much better. This is what I would call a perfect first layer. The final test I want to run is the flow rate test. This printer claims the maximum flow rate to up to 50 millimeters cubed per second. Normally, just like gas consumption ratings for cars, these claims aren't always accurate. I will start from 10 and go all the way up to 60 millimeters cubed per second to see how far it can actually go. At 20 millimeters cubed per second, it's doing fine. I still don't see any under extrusion or issues at 40 millimeters cubed per second. When it gets close to 50 millimeters cubed per second, I start to see some cooling issues at the front of the model. However, the back, closer to the auxiliary fan, still looks good. I'll let it finish so we can take a closer look. At the front, extrusion issues begin when the model's height exceeds 40 millimeters. Looking back at the slicer, we can see that at 40 millimeters, the flow rate is around 48 millimeters cubed per second. At the back, near the auxiliary fan, it reaches up to 48 millimeters in height, which corresponds to about 54 cubic millimeters per second. The actual flow rate turns out to be in line with, or even slightly higher than the claimed 50 millimeters cubed per second. Okay, let's talk about the pros and cons of this machine, starting with the pros. 1. The build quality is a beast. It has a sturdy frame, all metal panels, a glass top, and a glass door. The base is made from a 6mm aluminum plate, bringing the total weight of this tiny machine to nearly 40 pounds. 2. The flow rate of the hot end can reach up to 50 millimeters cubed per second with good cooling. and it still maintained 45 to 47 millimeters cubed per second, even when the auxiliary fan's airflow wasn't blowing directly on the part. This is based on my real-world testing, not just specs on paper, which is really impressive. 3. The motion system uses linear rails on all 3 axes. They're smooth and stable, even when printing at high speed. It's faster than most clipper machines I've tested, except for the FLSUN S1 Pro and the Creality K2 Plus, which cost 3 to 4 times more. The eddy sensor for bed leveling is incredibly fast. Scanning a 20 by 20 grid with 400 points takes just 10 seconds. That's way faster than any strain gauge or inductive sensor-based bed leveling I've seen. 5. The compact AC heated bed can reach 120 degrees Celsius in just 5 minutes. For a bed this size, it's also more energy efficient than larger beds, especially when printing small parts. The bed alone can heat the chamber to over 50 degrees Celsius when the machine is fully enclosed, making it ideal for printing ABS, ASA, and other temperature-sensitive materials. 6. The exhaust fan is powerful enough to let you print PLA, PETG, and even TPU with the chamber closed. It effectively pulls out excess heat and is equipped with an activated carbon filter to help maintain air quality in your room. 7. It runs native Clipper, so it's essentially a Linux computer where you can install additional software, plug-ins, and run your own scripts. It also uses the standard Orca slicer instead of a custom skin version, which is a big plus for users or businesses with printers from multiple brands who prefer to install and maintain as few slicers as possible. 8. Small improvements, like the latches to secure the glass top, the glass door that opens over 180 degrees. The print surface features alignment cutouts that make it easy to position, even with one hand. An Ethernet port, an extension port for connecting a touchscreen, and rubber pads on the bottom to absorb vibrations are all nice additions. Now for the cons. 1. It has a strong exhaust fan, which is great because you can keep the printer fully enclosed even when printing PLA and TPU. However, the enclosure doesn't make the printer significantly quieter, as the exhaust fan itself is fairly loud, reaching around 60 decibels at full speed. 2. While the print speed is fast, the surface quality is just average, indicating that the input shaper may not be fully optimized. Models with frequent retractions also yield average results, though fine-tuning the slicer profile should help improve this. 3. The stepper motors are standard, non-closed loop types. Using slightly more expensive motors with a closed-loop controller board would be a better fit for a printer designed for high-speed printing, as it could help prevent skipped steps. 4. The print volume is small. While it covers about 70 to 80% of what I typically print, there are always times when a larger build area is necessary. Some models can be sliced into multiple parts, but that approach doesn't work well for everything. 5. The machine itself is only 12 inches wide and is designed to have a small footprint. However, the power cord connector is located on the left side, and the spool holder extends out to the right for easier access. As a result, you'll need to account for about 2.5 inches on the left for the power cord and another 3.5 inches on the right for the spool, bringing the total required width to around 17 to 18 inches, nearly the same as the Prusa Core One, which offers a much larger print volume. It would be more space efficient if both the power connector and spool holder were placed on the same side. Left or right doesn't matter, as long as they're together. That alone could save 2 to 3 inches in width. Since the spool holder is now on the side rather than the back, it also helps reduce the overall depth requirement by about 4 inches. In conclusion, this is a tiny beast. The hardware specs are impressive, the build is solid, and it definitely has a lot of potential. However, for beginners, extremely large or ultra-compact machines like this may not be the best choice, especially if it's going to be your only printer. But if you're an advanced user who enjoys high-performing machines or want a platform for upgrades and experimentation, you're going to love this. Even for intermediate users looking for more than a beginner-level printer, it offers a Voron Zero-like experience without the time and effort of building it yourself. With its robust hardware and the freedom of open-source firmware that allows full customization, the Sovol Zero is definitely worth taking a look at. I've included a link to this machine in the video description, along with a link to my website auroratechchannel.com, where you can track prices for popular 3D printers, laser engravers, and CNC machines to help you compare and find great deals. That's it for this video. If you found this video helpful, please give it a like and consider subscribing to our channel. Thank you for watching, and I will see you next time.